Hello and welcome to session 3. In this session we're going to be revising UK airspace. Okay, why do we need to know about this? Well, even as pilots of hang gliders and paragliders, which we think of as an adventure sport, we're all commanders of an aircraft and we are subject to air law. The structure of British air law is laid down in this document, CAP 393, or Air Navigation, the Order and Regulations. And it's important that we understand the bits of airspace we're not allowed to fly in and the constraints of how and where we fly in the UK. There's loads of information in this document. In fact, it's a massive document, but the CAA have very helpfully simplified it, and they've produced this thing called the Skyway Code. You see the picture here, which is free to download from the CAA website, or you can buy a paper copy various places. The Skyway Code is obviously based on the Highway Code, and it has basically the essential information that's required for general aviation. So all the commercial stuff is out of there. It's just about private pilots planning their flights, but even that is full of information about radio calls, weather, stuff like that, and the rules that govern crossing various types of airspace. So there's far more in it than we really need as hang glider and paraglider pilots. So I've just sort of extracted out of it the main bits that are relevant to us as cross-country pilots. The structure of UK airspace. There's quite a lot of airspace in the UK if you look at an air chart, but we need to understand how it works, which bits we're allowed to penetrate and which bits we're not, and what the constraints are on our behaviour. We're all commanders of an aircraft, so we're subject to air law like any other pilot. So on this thing here, you can see there's a little extract from an air chart, and above it is this diagram which shows a little bit of airspace. So to start off, we'll just go through it in order. The bit that's immediately around the airport from the ground upwards is a control zone. And control zones, CTRs, I'm afraid there's a lot of jargon in this session. CTRs are something that we do need to be aware of, and as a rule we're not allowed to penetrate them. The next bit that's above it is a CTA, or control area. So this is something that goes from one altitude to another altitude, and it's a larger area in which the aircraft are making their approaches. Finally, above that, the huge area there you can see is a TMA, or terminal manoeuvring area, and a TMA is found around large international airports. In fact, a good rule of thumb is you have a TMA where you've got terminals in the airport, and that is where commercial traffic do their letdowns and are circuiting before they come into land. And then finally, section 4 there is an airway, which are the corridors of the sky where commercial traffic travel, and they're usually type A airspace as well. So that's TMA and airways. So I've already mentioned A's and D's and things like that, so we're going to have a look at the different types of airspace and what it means to us. Okay, so airspace classification. You look at an air chart and you will see that there are lines all over the place, and they all have these letters on them. So A is A-type airspace, and this is basically very controlled airspace. VFR flight, visual flight rules flight, which is what we're doing in visual meteorological conditions, is not permitted in type A airspace. What this means is everyone has to have the relevant instruments, and they're being controlled by air traffic control. So self-evidently you require the radio for that so that you can talk to ATC, and generally in type A airspace you're going to need a transponder as well so that you appear as a little blip on the screen and you can control. So we're unable to conform with that, so type A airspace is completely out for us. The next type is type C airspace. Not very much interest to us. Type C is fundamentally above, it's few airways, but most of it is above flight level 195, which is 19,500 feet. So unless you've got pressurized cabin and oxygen, it's not really much use. VFR flight is not permitted anyway. So a bit like Class A, we can't manage. D. Right, there's quite a bit of type D airspace, because this is the controlled airspace that you find around regional airports, that kind of thing. Class D airspace, it's not quite as tightly controlled as Class A. We're generally not allowed into it because you need to get air traffic control clearance, so you need to have a radio and so forth. However, it's slightly less busy than Class A, and therefore some clubs do have local letters of agreement, especially if they've got sites just underneath a bit of Class D airspace, or one of their sites is just clips the edge or something like that. But as a general rule, unless you've got a particular exemption, then Class D airspace is also forbidden to us. This is, I'm assuming I'm talking to hang glider and paraglider pilots. Now, if you're a microlight and you've got, or a paramotor, and you've got, so you can remain at a certain altitude as instructed by ATC, and you've got an airband radio, then of course you can request permission to transit Class D airspace. Class E. There's not very much Class E airspace. There is a little bit of it. It's all airways, and I think all of them are in Scotland, so only affect a tiny proportion of pilots. However, Class E is the only other kind of airspace that you are allowed to transit in VFR flight, so you don't need permission from anybody. So if you're flying in Scotland and there is some Class E airspace, the rule is that you can cross it, but you have to have full VMC. That is, I'll talk about the definitions of VMC and VFR in a different session. So in other words, you have to have good visibility, and there may be commercial traffic in there because this will be an airway. So it's a bit like a hedgehog crossing a road. You're allowed to, but you know, vigilance, and I'd get across it as quickly as possible. Okay, so that's Class E. And then Type G, which is all the rest. Type G is uncontrolled airspace, or the open FIR as it's known. Right, it's open, but it's not without its own hazards and rules. So we do need to know about the things that we need to conform to fly in Type G airspace. This little piece here is Type G airspace. But you see, even there's a Aerodrome traffic zone, military air traffic zone, a couple of airfields, aerodromes, that kind of thing. So there are still things we need to know about in Type G if we're going to fly in Type G airspace. Okay, so how do we stay clear of all the bits that we're not allowed into, which is basically everything except a little bit of Type E and Type G airspace? Well, we need three things really. The first thing is we've got to have an air chart. So an air chart, an aeronautical chart, one of these things is has got all the airspace marked on it. So you can see lots of stuff here. So we can see what is A, what is D, and so forth, and where we're not allowed to go. The second thing we need is to know where we are. It sounds obvious, but there have been cases of pilots, and I include myself in this, who've been flying with an air chart and still not knowing where they are or got lost. So it's important you know where you are so that you know, make sure you're not infringing any of that airspace. And thirdly, we need an altimeter. And this is because you can be on the chart and have a piece of airspace right over you, but you might be underneath it, or you might be above it, or it might be something that you're allowed to go through. So without having an accurate altimeter setting, you can't know that. So it's a three-dimensional game, as the earlier diagram showed. So you can often fly underneath or over the top of airspace. So you need your altimeter. Okay, so just look at these things in a bit more detail. So the aeronautical charts come in two flavours. There's the 250,000 chart, which is 4 miles to the inch. 250,000 air charts are quite easy to use, so kind of a good starter air chart if you like. The reason for this is they're not so cluttered. They only show the airspace up to 5,000 feet. So all the high level airspace is taken out of there, most of which we're not interested in anyway. And it shows a few more ground features. You can see on it, it's got lots of roads and small villages marked and that kind of thing. So it makes it easier to navigate and find out where you are. So that's the 250,000 chart. There are a couple of disadvantages. The first one, of course, if you get above 5,000 feet, you may not, there might be some airspace that you're not aware of. And actually the airspace technically, it's 5,000 feet AMSL or flight level 55, which sometimes comes up and down. It might come down as low as 5,000 feet, which we'll talk about in a moment. So the other thing, of course, if you have an air chart about this kind of size and you're on 4 miles to the inch, you've got quite a small area that you're on, so it's quite easy to fly off the chart. And then, of course, you're doomed. So try and refold an air chart in flight on a paraglider is not an easy thing to do. So there are some limitations. The other thing is if you fly in different areas, because they cover a small area, you might need to buy several charts. So they're kind of 20 quid a pop, and they become uncurrent every couple of years, so you have to keep buying them. So it's a significant expense. So that's the 250,000 chart. Or we have the 500,000 chart. So the scale is basically double. It's 8 miles to the inch, so it covers great areas of the country, so much easier to stay on the map. But they're much busier because they have all the airspace right up to high on it, which makes it more difficult to read, and it's more difficult to tell accurately where you are because a village is just a yellow dot on it, sort of thing. So if you're sort of a mile outside controlled airspace, it's quite difficult with the naked eye to say exactly where you are. One of the beauties of modern technology is if you buy something like a tablet or even a phone with a large display, you can actually get a 500,000 chart and then you can zoom it. So if you're like me, you need reading glasses these days, that's quite handy to help you use the bigger chart, but still be able to see yourself in a bit more detail. Of course, because it's cluttered, you need to be able to identify the types of airspace a bit more readily to be able to use it effectively. So that is the 500,000 chart. Okay, second thing is knowing where you are that I mentioned. Right, there's the three kind of basic systems. The first one is visual reference points. So especially if you look at the map beforehand, and ideally, frankly, not an air chart, which aren't that difficult to do, but an OS map or something like that, you can actually pick out things that are going to be easy to see from the air. So these are things like motorway junctions or a town with a lake just north of it, that kind of thing. Sometimes if something's easy to pick up from the air, you can mark it as a visual reference point, and then when you're flying you can spot it and think, okay, I'm heading towards that particular point, junction 8 on the A1 or whatever it may be, and that helps you to position yourself. However, you have to be careful what you choose. If you choose a small village with a church and there's lots of them around, it's going to be difficult to tell the difference between one and the other. So it has to be a sort of something that's quite unique, really. So that's visual reference points, which is one way of doing it. Another way is, you have to have your current air chart, of course, as well. There's the dead reckoning system, I think, is the way to refer to it. And this is if you know that you're traveling, say, east to west, and you know that your ground speed is about 30 kilometers an hour, let's say, circling flight, and you've been going for about an hour, then you know you've gone about 30 kilometers. The problem with that kind of dead reckoning process is it's fraught with complications. First of all, it's difficult to know what your airspeed is. It's easy if you're on a paramotor or something going at a pretty steady speed, but if you're circling flight using lift and what have you, then it's very difficult to judge, and it's quite difficult to say how far you've gone. And the second thing is that the wind might change. If the wind changes a few degrees, you might drift off track, be on a slightly different course. So it has its place, but it's still quite a skill to be able to use dead reckoning and visual reference points to find out exactly where you are. So I'd recommend GPS. Let the satellites do it for you. So if you've got a GPS system, or ideally, if you can do this regularly cross-country, I'd have two. So it actually gives you a little moving dot to show exactly where you are. They're not foolproof. They can sometimes go wrong. Particularly, they're not particularly good for altitude GPS systems, but nevertheless, that's the best system if you can do it. Okay, so know where you are is clearly critical. Right, altimeters. I mentioned you need an altimeter. You need an altimeter and it must be set correctly. So as you're probably aware, there's more than one altimeter setting. So I'll just run through those now. The first one is your height above a preset point. So this is QFE, or field elevation, query field elevation is the term. So you can set it to 0 at takeoff, or you could set it to 0 above your expected landing field, or you could set it to 0 at a goal field that you're going to, but it is above a preset point. So it doesn't matter what the datum is as long as you know what that is. Sometimes there are bits of airspace which go from the ground upwards. So if you set it to the ground level where the airspace is, this is the reading that you require. It'll give you an accurate readout. The second one is setting it above sea level, or QNH. Easy way to remember this is NH, nautical height. So in other words, if I'm standing on a hill and it's 1,000 feet high, I set my altimeter, instead of setting it to 0, I now set it to 1,000 feet. So I know my height above sea level. If I'm just boating around in a local area, then it's of no use to me. But if I'm going cross country, quite a lot of the airspace I'm likely to encounter is going to go up to a certain height above sea level. So this will be useful to me at that point. For example, cables from a tow site, say, will go up to 2,000 feet above sea level. So if I'm flying towards it, it's irrelevant how high the ground is or whatever. I just need to know how high above sea level I am. Okay, so that's QNH. Now the standard pressure setting or flight level is a bit like QNH in that it's set to sea level. However, it is set to a standard sea level, the ICAO standard atmosphere, which is if the pressure is 1013.2 hectopascals and the temperature is 15 degrees centigrade. That's the standard atmosphere. So we use that as a datum. Why do we need this? The fundamental reason is that because altimeters work on pressure and the pressure changes between one area and another, and from hour to hour, day to day anyway, the altimeter settings change. So if somebody was to set off in, say, a low pressure area where the pressure was 1010, let's say, and somebody else took off in another country where the pressure was 1020, then there'd be 10 hectopascals different, and each hectopascal of pressure is worth about 30 feet at sea level, so that's 300 feet different straight away. So one of them, if they'd set their things to QNH, one of them would actually say, oh, you're at 4,700 feet, and the other one would say you're at 5,000 feet, and then they collide because they're actually in the same place. So to prevent this from happening, we have a standard atmosphere, and we say, okay, everyone sets assuming the pressure is 1013.2. And that means that everyone's altimeters above a certain level are going to be, so airspace on the ground is usually from the ground up or sea level, but any higher airspace where people are going to be travelling some distance, anywhere that commercial aircraft use, we want to use a flight level. And then everyone's altimeter reads the same. So the flight level, as the pressure changes, moves up and down, but it doesn't matter because everybody's got the same reading on their altimeter. So now this guy's at 5,000 feet, this guy's at 5,200 feet, they're going to be 200 feet apart, simple as that. So it's just a standard datum. I hope I've explained that okay. The reason we need it is because that airspace moves up and down. If we're going to negotiate that airspace or fly underneath it or over the top of it, we need to know where it is, not only in terms of geography, but in terms of how high it is above the ground. So the standard pressure setting allows us to do that. Okay, and that is the standard 1013.2 hectopascals. If some of you have been flying for a long time, you might be familiar with millibars. A hectopascal and a millibar are exactly the same, in fact, in terms of their sort of quantity. And a hectopascal is, as I mentioned earlier, is worth about 30 feet at sea level. So there we go. Right, uncontrolled airspace, so we're out in type G airspace, but there's still some rules and there's still some hazards that we need to avoid. So we're going to have a quick look through those. Hopefully all our flying is going to be done in type G airspace, unless you're lucky enough to fly through a little bit of airway in Scotland or something like that. So what do we need to know? VMC. Because we're doing VFR flight, that's flying under visual flight rules, we have to fly in visual meteorological conditions. So I'll explain what those are in just a second. You must be able to see where you're going, so we're not allowed to fly at night without an instrument rating, so we have to fly during the hours of daylight. Fairly self-evident. We have to adhere to the low flying rules, because it doesn't matter what airspace, even outside airspace, there are low flying rules that we have to, that are part of the law. We have to respect prohibited and restricted areas. So there's still patches of places we can't go, or we can only go under certain circumstances. Danger areas, we're not allowed into those when they're active. Military aerodrome traffic zones. These are another potential hazard. MATZ. The MATZ, we'll look at one of those in a minute. You are allowed to fly through a MATZ, you're allowed to penetrate one, but there are obviously hazards associated with that, so we'll look at that. There are other areas with hazards. Areas of intense aerial activity, areas of high intensity radio transmissions, lots of things like that. So we need to know about those. And just make sure that we know what the rules are, and so that we don't cause ourselves a higher risk of conflict or in case of high intensity radio transmit, possible injury by flying into them or staying them in too long. So VMC, this is the first one, VMC, right? This picture here shows, this is from the Skyway Code, and this actually shows the different levels and the different levels of visual meteorological conditions. Now it's nice, and I've blanked out all the things because normally I'm doing this talk to people who, you know, I then ask them what do they all stand for. So I'm hoping you're all at home looking at it and say, I know what that is, I know what that is. But as this is a one-way thing, I'm just going to tell you the answers. So here we are. So if you're above 10,000 feet, so up high, so then basically you've got to have 8 kilometers visibility, and you've got to be clear of cloud by 1,500 meters horizontally and 1,000 feet vertically. Easy as that. Okay. Obviously, if you're up high, your altimeter's up there. There's controlled airspace, so you're going to be on a flight level. So it's flight level 10, so 10,000 feet. Below flight level 10,000 feet, but above 3,000 feet AMSL, so notice we're now on QNH, then there is a slightly relaxation to that, and VMC then becomes 5 kilometers visibility. The distance from cloud is the same, still 1,000 foot vertically, 1,500 meters horizontally, but 5K visibility. Okay, the bit that's of particular interest to us hangar and paraglider pilots is below 3,000 feet AMSL. It's relaxed again. Right, when I say relaxed again, the actual rule is that you must have visibility of 5 kilometers and you must be clear of cloud and within sight of the ground. So that's the rule. And then different countries have slightly different exemptions to this rule. And in the UK, there is an exemption that's saying if you're traveling at less than 140 knots, which hopefully we will be, then the visibility is reduced to 1,500 meters minimum visibility, which is really, really low. So if you're below 3,000 feet AMSL, clear of cloud, sight of the ground, must be daylight obviously, with visibility of at least 1,500 meters. I mentioned that's an exemption, not the rule, because if you fly in some other countries, they don't have that exemption and it's always 5 kilometers, which is probably not a bad idea. Anyway, so those are the VMC minima. One little wrinkle worth pointing out here, and that is 3,000 feet AMSL. So if you're taking off a hill in the Lake District or a mountain in Scotland or Wales or something, and you're taking off at 2,000 feet, you've only got 1,000 feet, and then you're up to the higher viz requirements. Okay. Right, pushing on, night and day. Pretty simple this, you just have to know this. Essentially, the day starts 30 minutes before sunrise, as seen from the surface, and finishes 30 minutes after sunset, as seen from the surface. The kicker is the last little bit at the surface. It's quite easy if you're flying on a big mountain or a nice westerly sight and you're watching the sun go down in the distance. You know, it's all very pleasant, and then you go down and land, and then you land in the valley and suddenly it's pitch dark. So because you can still see the sun if you're at 1,000 feet high, you can still see it for a lot longer than someone at the surface. So basically, when you're flying, as soon as the sun is, you know, going to go down, you want to be landing. You don't want to be taking advantage of that half hour. And in fact, because we're up high and we have that view, if you're very high, I've done this in Turkey from sort of 6,000 feet and watched the sun, I could still see the whole disk of the sun. And yet by the time I got down to the bottom, sort of 25 minutes later, it was pretty well pitch dark. So do watch out for that. Don't hang around too long watching the sun sink. We don't have too much problem with pilots flying before dawn, so I won't worry too much about that. The reason you need to land in good visibility, because you can see down and see something, doesn't mean that when you get down there you'll still be able to see it, if you follow my drift. And the worst offenders for this are power lines. Power lines become absolutely invisible. Your eye just can't pick out a thin black line against the ground clutter in poor visibility. Okay, so that's day and night. So low flying rules. There are some low flying rules that we have to adhere to, so I'm just going to run through those. Number one is the 500 foot rule. It is illegal to operate an aircraft within 500 feet of any person, vessel, vehicle or structure, unless, and we have an exception here, again, you're taking off or landing in the normal way, or you are a glider that is slope soaring, ridge soaring. So obviously if you're soaring on a ridge, then that's fine. If you're taking off or landing, that's fine. And even if you're powered, you know, we can always say that we're landing, if you like. So we usually are landing. However, If you blatantly disregard this rule, for example, someone on a paramotor flying along at 200 feet or dragging their foot along through you know, the water in a canal or something like that, then you are breaking the law and breaking that rule. So that's the 500-foot rule. Okay. The second one is the 1,000-foot rule, and this goes together with land clear. So this is, if you fly over a conurbation, so a built-up area or industrial area or a town, anything like that, or a gathering of 1,000 people or more, so it includes football matches and fetes, anything like that, you have to be 1,000 feet above the nearest fixed obstacle or object within 600 meters radius of your aircraft. Okay. Or sufficient height to land clear, whichever is the greater. So if you're 1,000 feet above the Shard in London, assuming that's the highest point, I guess it is, it's still no good to you because you're still not high enough to land clear, so you have to be higher than that. The rule goes on to say, you know, in the event of you know, an engine failure or something like that, but of course we haven't got engines usually, so it just means be able to glide clear. So if you're flying over any town or anything like that, you must be 1,000 feet above the nearest fixed object, and if it's a big town, it's got to be higher than that. Okay, so that's the 1,000-foot rule. Land clear, I've just mentioned. Launching, right, this one's slightly less commonly known, but it has an effect on us. You cannot take off within 1 kilometre, 1,000 metres of a large gathering. So if you have like an outdoor fair or something like that, you can't just take off a hill above it. Even if you're 1,000 feet up and you can do the land clear, you're not allowed to take off within 1 kilometre. So it's just one of those rules that just occasionally rears its head. So those are the low flying rules, basically. Display pilots, right? This picture here shows somebody obviously much closer to those people, and there may be building some things around. So clearly this guy is a display pilot, because if you're a display pilot and you have a display authorization, you can get an exemption from the low flying rules. The exemption is written down in what your display does. So if you do want to fly into a football match or a fete or whatever it may be, or fly at an air show even better, then what you need to do is apply to the Civil Aviation Authority, and a display authorization examiner will come out, watch you do your stuff, decide if you're a good chap and if you can follow the rules, and you're capable of controlling your aircraft safely, and they will issue you with a display authorization which lasts for a certain amount of time. They have to keep being renewed. Okay, so that's a display authorization. Quite a few hang glider and paraglider pilots do hold these. Right, restricted and prohibited areas. We'll come across these on the air chart. It's one of the features of an air chart. They're dotted all over the place. Basically, anything with diagonal lines like this is a restricted area, a prohibited area, or perhaps a danger area. Restricted and prohibited tend to be circular. How do you tell the difference? Well, I'll do a little close-up of this, but basically they've all got a number, and if the number starts with a P, then it's a prohibited area, so P615 for example. If it starts with an R, R315, then that's a restricted area. So what's the difference? Prohibited areas you can't go into, it's as simple as that. Restricted areas are either restricted in terms of time, so they're sometimes or other times, or some people are allowed in and other people aren't allowed in, usually the latter. Right, there's other variations on this. These ones have got solid outlines. Sometimes they have a dotted outline. If it's a dotted outline, then it means it's temporary, or only active at certain times, and there's usually a note next to it. So you look on the air chart note, say it's note 11, and it says, oh, note 11 only on bank holidays, or whatever it may be. So those are prohibited and restricted areas. Usually they do have a note next, and if they don't have a note, then it just means it's permanent. Okay, and some of them also have a little strange little symbol, which means that implies that there's a note about it, and that gives you the phone number that you can ring. So there we are. Okay, sometimes they'll look like this. This little one is actually taken from a digital air chart, and it's just displayed slightly differently. So this restricted area 212, which goes from the surface to 2,000 feet. FSC is just short for surface, obviously. Okay, next thing is danger areas. Similar thing, diagonal red lines means keep out. Solid outline means it's permanently there. And the number starts with a D, which implies it's a danger area, which is nearly always a shooting range or artillery or small arms fire or something like that. Right, the way they work is, and this applies to restricted and prohibited areas as well, they have the number, so the P, the R, the D, and then the number, and then a slash, and then after that there's another number. On this one, danger area, it's 10.0, which means that's the altitude that it goes up to above ground level. So this one is up to 10,000 feet. In fact, and this one says OCNL 13.5, so occasionally to 13,500 feet. So this particular one is bad news. You can't get over. Sometimes small arms fire, you'll get danger areas that only go up to 3,000 feet or something like that. So you may potentially be able to fly over them. So that's what the numbers mean. It means this one is danger area number 407 to 10,000 feet, occasionally to 13,500 feet. Okay, the little asterisk at the front is just pointing out as well that it's a permanent area. Military Aerodrome Traffic Zones, or MATZs. Okay, there's quite a lot of these dotted around as well. In some areas of the country more than others. A MATZ is kind of a shell of airspace around the military aerodrome traffic zone, which is forbidden to us. But the MATZ itself, its larger, is basically just a warning saying this is where there's going to be intense military activity and fast-moving aircraft very often. It's not forbidden to us. It is legal in VFR flight to penetrate a MATZ. But, and it's a big but, if you're flying along and it's you know, Monday to Friday, and you look down and you can see a military aerodrome traffic zone, you can see aircraft on the pan or on the runway, or jets flying around, you'd be crazy to go into it, because that's where they're just you know, on their finals and what have you, so they have very high workload, and you know, the risk of conflict is very high. If it's a weekend and you look down, there's nothing there or what have you, and it looks like you're just going to clip the MATZ, you know, you're trying to decide whether to glide over it, and you're 3,500 feet or something, you think, well, I can't guarantee I'm going to be missing it, then it might be worth a shot, especially if you're going to go close to the edge and you're flying in a straight line. It's up to you to decide. So it's not actually forbidden to us, but it is a hazardous area, the MATZ. Okay. MATZs, incidentally, here's some information about them here. This actually shows the dimensions. So basically the round bit is 5 nautical miles. Sometimes they have these stubs. This one's got 2, sometimes they only have 1. Sometimes 2 of them are stuck together, so you get a MATZ and another MATZ, a combined MATZ. But all those are areas where you can expect the traffic. The stub is usually lined up with the longest runway. If you've got a bit of nous, you can actually figure out if the runway is northeast southwest and the wind is southwesterly, then you can figure out which runway they're going to be using and whether, you know, where the traffic is going, if you see what I mean, which makes it a little bit easier to make the decision about avoiding potential traffic in the MATZ. Okay. One other thing about MATZ is they nearly always, this one here has got a frequency as well. If you do have an airband radio and you've got a license to use it, you can actually just call them up. And you know, if you're flying a powered aircraft or a microlight or whatever, and you've got a radio, you can just call up the MATZ. They're very nice chaps, and just say, yeah, I'm planning to fly through the stub of your military aerodrome traffic zone at you know, 1,800 feet. Is that all right? And they'll either say, yeah, go ahead, there's nobody around, or they might say, whoa, well, I wouldn't bother if I was you. You know, there's a lot of traffic going in, so at least you know. Okay, so that's a MATZ. Inside the MATZ, and you can see in this diagram here, is the ATZ. Unlike the MATZ, the ATZ is prohibited to us. So like the ATZ around any aerodrome, 2,000 feet high, and it's yeah, it's a red zone. So there we go. Okay, every military aerodrome traffic zone has an ATZ inside it. So some other things that you need to know. So looking at the air charts now. So this, the blue diamonds. This, in uncontrolled airspace, there are still areas where there's a lot of activity. So to warn pilots, they put these blue diamonds around. So that shows the outline of an area of intense aerial activity. Doesn't mean you can't fly there. It just means basically you need to be very vigilant when you're going around. It's just a warning, really. So area of intense aerial activity. The next one, the round thing there, that's the ATZ. So that's forbidden to us, aerodrome traffic zone. Okay. This one here is it's just a general hazard. This one's taken from a digital air chart, so it's got a slightly different look for it. And that just, anything that's got a round circle like that with the diagonal lines is somewhere that you want to avoid. That particular one I think is a gas venting zone, so there's various things that they could be, any kind of hazard. This one, if it's got vertical and horizontal hatching, slightly different. That is a high intensity radio transmission area, or a HRTA. They will very often have a note with them. It's a good idea to stay out of them. You are allowed to penetrate a HRTA, however, some of them can be quite hazardous to your health if they've got strong microwave radiation. So, for example, there's one fairly near where I fly, and it says the outer shell you can fly through, but don't hang about. The inner part of it, you know, we do not recommend you there for more than 1 minute, or you may suffer the consequences. So, you know, up to you. Okay. And this one here is another danger area. I put this one in because it's got a little symbol, and if you can see the symbols here, maybe look a little bit more closely, at the beginning, a sort of double S symbol, and that just means that you can find out more information about it, and you can call up a radio frequency if you've got the right radio, or you can make a phone call to an air information service of some sort, which will be able to tell you more details about it. So if you've got one of those, you can't do this in the air, or we can't anyway, but if you look on the danger area and you think, oh, that's in the way, I think I'll find out, but you can actually ring them up and find out what the situation is and whether it's active or not. Okay, so there we go. Anything else? Yes, a couple of other chart symbols. So little X through it just means it's a disused airfield or aerodrome, just worth knowing. One, it's got little sort of a stubs, north, south, east and west. That just means it's got facilities, so fuel and all that kind of thing. It's worth knowing about this because the next one, which is just a standard aerodrome that doesn't have that, is likely to be not so busy. If it's got facilities, then it means it's a bit of a bigger operation. So more likely to have traffic around it. So it's just a bit of information there. So that's with and without facilities. High lighted objects, it's not a problem to us. We can see those pretty well. If you have an aerodrome like that with an M in the middle, the little round symbol, then that means there's microlights operating out of it. If it's got a G in the middle, it's gliding. If it's got an H, it's helicopters, what have you. It just gives you an idea of what's using that particular airfield. Okay, this sort of one with a duck in the middle is a bird sanctuary. Bird sanctuaries are sometimes restricted and sometimes prohibited. It depends on which one it is, and there's often things about times of year. Some are permanently out of it and some of are breeding season only, that kind of thing. So they'll usually have a note next to it, and again you look on the air chart legend and it tells you about it. Okay, or you can check with the Aeronautical Information Service. Okay, right, this one here, this is slightly different to the disuse. This is a vertical plus sign inside a little circle. That just designates a VRP, or visual reference point, that it's very easy to identify from the air. So this particular one is a marina, so obviously a big, you know, cutout next to the river with lots of boats in. Typically they're motorway service stations, things like that. Humber Bridge is a good one near me. Okay, the yellow bits, by the way, are towns and villages. So yellow is irregular shape is a town. A yellow dot, this on a 500,000 chart, is a village. Okay, so those are the main features of an air chart and a quick guide to the structure of UK airspace. So the takeaway things from that is, if it's marked on the air chart as controlled airspace, so you know, A or D or whatever it may be, then we have to stay out of it. And if it's uncontrolled airspace, we need to know what all the features mean, and also obviously to navigate it we need to know where we are and our altimeter and all that. So I hope that's been a useful grounding for you, and hopefully now when you open an air chart it won't be quite so difficult to interpret. Okay, I hope that found that useful.